Okay, well, let's say if I go back to my general picture of a map from a vector space V, a linear map between a vector space V and a vector space W, we've dealt with the range space, and here's a picture of V and W. And inside W, let me draw these not so going uphill. Here's we do a better job on that. Oh, what am I doing here? This is not working. Okay, apologize for I'm not sure why exactly, unless I'm losing all my ability to draw. Okay, well, that's there. Here's V and W, and here's the range space. There's the zero vector. Okay, well, now we can ask, if I choose a vector W over here, I can ask for the set. The inverse image is the set of all the V's that go here. So the inverse image, sort of like the inverse image of W is the following set, is all the V's such that F of V equals W. Well, it could be that if I chose a V out here, it wouldn't be in the range space. So this could be the null set. There might not be any V's. Or I could choose it in here and there might be one V or many V's that are mapping to this one vector here. So this is the inverse image of W. We could give it a name of sort of like F inverse of W. So this just means the set of all the vectors that map to W. Okay, well, it turns out that we could ask, what are all, there's a special set, which is all the vectors V such that F of V equals the zero vector. This is called the null space. Sometimes it's called the kernel, and I've sometimes written K for it, but I'm trying to go back to just using N for the null space. The null space is all the vectors in the domain. So it's the null space is the set of vectors in domain that map to the zero vector in the codomain. And it turns out, so here's N. Here's all the vectors that map to the zero vector. It turns out that this is also a vector space. One of the vectors in here is the zero vector. Okay, so why is that? Well, let's look at this set here and ask, it's a subset of the domain, but is it a vector space? Well, again, let's choose an arbitrary, let's choose V1, member of the null space, V2, member of the null space. And we know it's a vector space. It's a subset of a vector space, but is it a vector space itself? Well, we have to see is RV1 plus SV2 also a member of the null space? Well, let's see if we can, what we can say is, we can say that we want to know, because this is a member of the domain, there is an image F of RV1 plus SV2, because F is linear. We know this exists, the image, but we know it's because F is linear that this is equal to F of R times F of V1 plus S times F of V2. And because V1 is a member of the null space, we have R, the zero vector in the domain, plus S times the zero vector in the domain, in the codomain, because V2 is also in the null space, so that just equals 0. That means this is also in the null space. So the null space is well known. It is a vector space. The null space is a vector space, which is why it's called a space in the first place. Okay, the dimension of n is called the nullity of the map. So if we want to find the nullity, we have to sort of find a basis for the null space. Well, let's look at our last map here. Let's see. Yes, I can write that down. Let me repeat the map here. Even if the name changes, x plus z, y plus z, and ask, well, how do we, so the null space is basically a set of domain vectors, x, y, z, such that x plus z, y plus z equals 0, 0, equals the 0 vector. So this is the linear system. So we have to sort of solve this linear system to see whether to find the null space. Well, this is x, the equation is x plus z equals 0 and y plus z equals 0. And this is in echelon form, so we can solve for the leading variables x and y in terms of the free variable z. We have y equals minus z. It's actually in reduced echelon form, and x equals minus z. So we solve this constraint that for these conditions on the domain components, we get the 0 vector here. So the null space equals, we can minus z for x, minus z for y, and z is z, such that z is any real number. We can factor out the z here, the dependent or free variables, to get z times minus 1, 1, such that z is a member of R. And you can see that this one vector here provides a basis for null space, so that the dimension of n equals 1, because we have one vector, and therefore the nullity of the map M equals 1. So that gets you, that's what you have to do for these practice problems here, is what is the range space, what is the rank, what is the null space or the kernel, and what is the nullity. And these problems are on isomorphisms, but then here, range space, rank, kernel, nullity, range space, rank, kernel, nullity. And then, so the first 5 problems, we sort of have a complete story about what to do. Now, just as a comment, it's going to turn out, it's not so hard to show this, that a map F is onto if the rank equals dimension of domain. So rank has to be the max. The rank is a dimension of a subspace, the range space. And so if it's large enough, if it covers the whole, if it covers all of n, of the codomain rather, then it's good. Then the range space will equal the codomain, and the map will be onto. A map F is 1 to 1 if the nullity equals 0. That is, if the null space the null space can't, if in that case, the null space is just the zero vector. So if the null space is not the zero vector, if it's not dimension 0, then the map is not 1-to-1. If it has any non-zero vectors, the map is not 1-to-1. So that the rank and nullity tell you about whether a map, how badly, they provide a measure of how badly a map is not 1-to-1 or not onto. Okay, so let's go and practice this maybe. Here is a map, say H. Here's a map H. So the question is, what is the range space and the rank, and what is the null space and the nullity? So see if you can work through that for this map H, and then maybe you can ask questions when you get stuck.
I think I know it.
Okay, so range space.
The range space is the rank, right?
No, the rank is a number. The range space is a vector space. Which to revise your answer, you said you think you know the rank and the nullity, right?
Yeah.
But the first question is, what's the range space?
Okay. Hold on.
Well, I mean, yeah. So I'll hold on while you do the calculation. So you want to exhibit the range space as a span of a basis. So the answer to the question, what is the range space, is a vector space defined as a span of a basis of the range space.
Okay. So it would be X.
Wait. You're telling me what to write?
Yeah.
Okay. What do I
X.
write? No.
Oh, okay. So
Yeah,
it's not the whole span.
What is the first thing I write?
Uh,
I can't write X here.
okay. It would
What
be,
what do I first write?
would it be, the, is that an R or a
That's
K? Which is,
this is the range space.
yeah, that's the range space, but
This is a curly R.
that's a curly R, but the thing above the arrow is what I'm looking at.
That's H.
That's H.
That's
Okay.
the name. This is the name.
Yep.
So, okay, so let me write this back. This is the range space of H
yep.
equals.
The range space of H equals X, Z,
No,
Y,
no, you
Z.
have to. What do I write? Tell me what to write.
That's what I think you write. You write the vector again, don't you?
Well, but that's not.
Where X,
Well,
Y, and Z are real
that's not going
numbers.
to be the first symbol here. What do I have to? What's the first? What
Oh,
is the
curly
range?
braces.
Yeah, you have to write the curly brace because it's a set, right?
Yeah, a curly brace, then
Okay. A vector
um,
symbol.
yep, vector
And
symbol
what do I write here?
X, Z, Y, Z.
X, Z, Y, Z.
Hard bar with X, Y, Z are real numbers.
Okay, so this is the first step, right? That's the definition, but that's not the answer. That's not
Yep.
the final answer. You have to continue on down to the final answer, which is
Curly braces, X, vector, Space 1000 plus y vector space 0010
Vector, you mean, instead of vectors.
vector, sorry, and z 0101.
Yep. Times, and then just X, Y, and Z, member of Z. Okay, so that's the range. So this is the range space of H exhibited as the span of three constant vectors. So here's your candidate basis. Now they span the space. What else do you have to check?
We have to check for the rank.
No, you have to check.
Oh, the nullity.
No,
Oh,
you have to check that it's a basis. You have to sort of verify
They're
or
linearly
state
independent.
that they're linearly independent. Right? These aren't a basis unless they're linearly independent, right?
yeah.
Well, these are linearly independent. So they do form a basis for range space. So what's the rank of H?
The rank would be 4, or
Why 4?
because there's 4
Components?
components, yeah.
Is that correct? Is the rank the number of components in the basis? Well, that would mean the rank of all the rank. If you have a map,
No, it would be the rank of
wouldn't the rank of any map to R4 be 4 then? Because
not
they'd always
necessarily.
well then
Then it would be 3 because you can cancel out the 2 z's.
no, you can't cancel out the 2 z's. The point is this: has nothing to do with the number of components. There could be 1,000 components in each of these, and it would still be rank 3 because there's 1, 2, 3 vectors
Oh,
in the basis. So the basis would equal 1, 0, 0, 0, 0, 0, 1, 0, and 0, 1, 0, 1. That's the basis. And there's 3 vectors. 1, 2, 3. It has nothing, it doesn't matter. There could be 1,000 components in each vector, and it's still rank 3.
okay.
Okay, so now that's the first bit, right? Then you have to go back and say, for this map, what is the null space?
1.
Okay, the null space again, you're confusing the null space with the nullity. The null space is a vector space. The nullity. So your claim is the nullity. What you're saying is you think the nullity is equal to 1. Now, that means that the null space only has one vector.
I thought the nullity would be the
number of vectors in the basis of null space. So we need to figure out what is null space. It's a vector space. So you have to do the same thing for the null space that you did for this space. But it's not, the range space is not defined to be over here. How is it defined to be? What's the analog for the null space of this first line here? This was sort of the definition. This is your starting point.
and you start there for the null space as well, correct?
No, this is you don't start here at all.
Just for the rank. Okay.
Because the range space is a subset of the codomain. The null space is a subset of the domain. So you're going to start off here with X, Y, Z. See, the range space starts with this side, it's all of these. The null space starts with the left-hand side, but it's not all of them. It's only the ones of these that are 0. So so there's a constraint over here. What's the constraint?
That they're real numbers?
No.
Is it that X, Y, Z is all equal to a 0 vector, the 0, 0, 0, by chance?
Yes, what you have to do is you have to put in X, Y, what is it? No, x
XZ, YZ.
z, y, z equals 0, 0, 0, 0. Well, what is this constraint? This is the this, if you wrote out each equation, it would be x equals 0, z equals 0, y equals 0, and z equals 0 again. So they're all 0, right? Which means the null space is 0, 0, 0. There's just
Oh,
one vector. Now, what is a basis for this space? What's the basis for this space?
0, 0, 0.
No, you want to ask how many, okay, the basis is what you want to put in here is the vectors needed, the non-zero vectors needed to get this one here, right?
Mm-hmm.
That are linearly independent. Well,
XYZ.
but there are no vectors you can put in here, because if I can't put 0 because that's not linearly independent. I can't put any non-zero vector because I don't have a span. There are no vectors. So the basis for n is the null sequence, or the null set. Okay? It's like the empty set.
Okay.
How many elements
And
are in the
this
empty?
is how you represent null basis.
Yeah, I just
Okay.
make that up and say this is the null basis, right? It has no vectors, no non-zero vectors.
Okay.
So what is the nullity?
3.
Not 3. It's not the number of components. It's the
Oh,
number.
it's the number of
It's the
vectors, so
number.
1.
How many vectors do you see in here?
0.
0. So the nullity equals 0, not 1. Okay. So the nullity equals 0, and the rank equals 3. So the rank equals 3, nullity equals 0, and the map H goes from RC3 to RC4. Now, is map H 1-to-1?
Yes,
Yes. Why?
because the nullity is 0.
Yes, because nullity is 0. Now, you might have to go through, because and I mean there's 2 ways. So there's 2 ways to show that a map is 1-to-1. You could actually check the definition literally, right? By saying, okay, if I have 2 vectors that are say A1 is not equal to A2, then f of A1 is not equal to f of A2. Or you could start from f of A1 equals f of A2 and prove that A1 equals A2. You could prove it directly, or you could just find the nullity and find, oh yeah, the nullity is 0, so it's 1-to-1. Now, is it onto? Well, that for here, for detection schemes, the question is this number the same as the dimension of this space?
No.
No. So it's not onto, because rank not equal to dimension of the codomain. Okay. Let us do another one. Let's say that we have the map, say G here, from XY to these numbers is so what is the range space of G, and what is the null space of G, and what is the rank, and what is the nullity? These are numbers, these are vector spaces. And so the answer to these questions is a set, a span of basis vectors. The answer to these are numbers.
Do you mind scrolling up a little bit? There we go.
Oh, you want to be able to see the map, right? Like this. Is that okay?
Yeah, that's fine. I wasn't trying to see the map, just
Oh, you just wanted to, oh, I see, you're copying, but you're okay now? Oh. Why did I draw it that way? I don't know if I meant to. Okay, that's fine.
I think I got it.
Okay. So
So for the
Range,
range, it
okay.
is curly braces 2x plus y, vector 2x plus y.
Professor, excuse me, can we have like 2 minutes to finish, please?
Okay, yeah, let's have, okay,
Oh, I'm sorry,
let's,
Patrick.
Yes, we'll go on. Good. Yes, if you want to raise your hand when you're finished, I get a sense for how many people have answers. Either how many people have answers, or if you give up. So Patrick, you're ready now?
Yeah, I mean, I
Okay.
think I have some, it might not be correct, but you know, at
Okay.
least I can. You know.
Do you want to tell me your answer? Do you want to see Will's answer or what?
I can give mine. If I'm wrong, then you're correct. You know.
Okay.
Go ahead.
So my range is it's gonna be, yeah, bracket X.
Oh, X. Okay.
No, not X, no X, no. That's the next one after. So I have the first element ZX plus Y after the bracket, yeah.
You have a parentheses, right? For
Yeah,
vector.
yeah, ZX plus Y. And then the second one, Y plus ZX.
There's
And
no
then
Z. There's no Z.
I mean Y plus
Or 2X plus Y. I just wrote it backwards, right?
2X. Oh, I thought then my answers might not be correct. I thought that was Z for some reason. Sorry. I have
Oh
to do
yeah.
it.
Okay.
Yeah.
Well, Will, you had this, right?
Yeah, that's what I had, and that's the answer, right?
No. Well, no, it's the
well, that's the
starting,
answer for the first. You have 4 questions on the
but
board,
no,
right?
it's not the answer for any of them.
Oh, okay. So is it
Remember, you want to write the range space as a free variable times a basis
okay?
vector.
So then the range space would be x equal, I mean parentheses.
There's not going to be any
Oh,
x's or y's in the parentheses.
oh, sorry, x parentheses. It would be y divided by 2. Or negative y divided by 2.
You
No.
can't have any you can't have any variables in here.
Ugh.
Does anyone else have any ideas? Well, I can write in my choice. R times 1 for R any real numbers. If I did it
y.
if I factored out the X here, I'd have X times 2 plus Y. x times 2, 2 plus y times 1, 1, such that x and y are real numbers, right? But
Mhm.
those are linearly dependent. So I can choose one of them.
Then you chose 1, 1, but why R?
Why not?
Okay, just it
In other words,
just
that,
seemed
that
out of pocket. That's all.
I could choose y, or I could choose x.
Okay.
The point is I could choose, yeah, so you could choose here, for example, this would be possible, x times 2, 2, right?
Mm-hmm.
And then my basis, b, would equal 2, 2, or I could choose y, or I
Which
could
would be
choose, see, the point was I can say this is equal to 2x plus y times 1, 1, such that x and y are any real numbers. And then the point is, this number here I could call r, right?
Yep. Okay.
So the point is, but then so this, any of these answers are good, right?
Mm-hmm. But
So,
that
so what's
means that since there's one vector in the basis, the rank would be equal to 1.
yes, the rank is 1. Okay, well, let's see. Patrick, did you have an idea for the null space, or did maybe you want to just wait? Anyone else have an idea for the null space?
I have an idea for the null space, but if Patrick wants to go,
Or anyone else?
okay. So for I got curly bracket, soft bracket XY.
Soft bracket, you mean vector?
Yeah, the parentheses, the vector space. Sorry. XY.
What do you mean XY?
Don't you start out with the domain?
Oh, yeah, okay, yes. So XY, I see what you mean. Yeah, sorry about that.
No,
Such
you're good.
that,
Such that 2x plus y equals 0 over y plus 2x equals 0. Oh, yes.
okay, and then that reduces to,
X equals negative y over 2.
you mean you want to put that as a component?
Yep, and then negative 2x. Those were my two components. Because
X and Y, this is one equation, 2x plus y equals 0, right?
yeah.
I can solve for the x equals minus 1/2 y. But then I just leave this as y. I don't solve, this is like,
Oh,
you solve for the leading variable in terms of the
okay.
free
Since
variable,
it's a
but
free
you don't,
variable,
but you don't, there's only two variables, but you don't reverse it. So this is equal to y times minus 1/2 1, such
okay.
that y is a real number. So that this is a basis for null space, right?
Mm-hmm.
So what's the nullity?
The nullity is 1 because there's one vector.
Right. And is this map 1-to-1?
No, because the nullity is 1.
Well, yes, the
It
nullity
is.
is 1, not 0. Patrick?
So I
Or
was just saying it's 1-to-1.
yeah, it's not. Yeah, so this shows you, right, it's not 1-to-1. And what about onto?
No as well.
Yeah, no, it's not onto, because the rank not equal to 2, the dimension of the codomain. So it's neither 1-to-1 nor onto. Okay, let's
Is it
do,
linear though?
oh, it's linear. Yeah, these are all
Okay.
linear maps. Okay, let's do one last one. it's appropriate for 4 minutes. H, let's have map K, X, Y, Z goes to 0, 0. So this is map K, K from RC3 to R2C. So what is the range space of K?
So it would be curly bracket, for the starting point soft bracket, or vector space 0 over 0. And,
That's it.
yep.
Okay. So what is the rank?
That I'm confused about. Would it
Okay.
be 0 or would it be 1?
The rank is 0 because this is not a basis. The important thing is this is the 0 space. The question is, so you can't, how many, if you can't put the 0 vector in here because the 0 vector is linearly dependent.
Okay.
Okay.
So the
So,
0.
so the point is then, but you can't put a non-zero vector in here because if it was, you wouldn't just have the 0 vector. So the only vector, there aren't any vectors you can put in here to capture this space. So it's the null basis.
Okay. So a basis has to have a non-zero component to be in a basis.
It has to be linearly independent, right? But 0,
Yep.
0, the only vector you could conceivably put in here would be 0, 0, right?
Yeah.
But
Oh,
0,
okay.
0, but 0, 0 times A, if I set that to be 0, does that imply that A equals 0?
No.
No, because I could choose counterexample, choose A equals 1. Therefore, this is 0, 0 is 0, 0 as a vector is linearly dependent.
So I guess
There are no vectors, so the basis can't have anything in it, so its rank is 0.
so the question that I have isn't based on this problem itself, but if there was a vector with only one component in it, which is 0, could that be put in a basis? No, because A could still be anything.
If what are you thinking of a vector to go in here, a candidate vector in here,
No. I'm thinking
of a
of
different
it,
space?
yeah, of a different space, just a 1, 0, and then that's the vector space.
That's not a vector.
No one, just a 0. So
Well, that's not a vector space.
no, not an A.
Oh, I mean,
Just
with A
one
is any.
component. No. One
Okay.
component in the vector that's 0.
Oh,
So no A, just 0.
you want to have a one component vector?
Yeah. Could that be a basis?
No, because it's linearly dependent.
Okay, thank you.
It's the 1 by 1 case doesn't work. Okay. What about the null space? What's the null space of K? Well, since this is 0, it's everything. It's all of R3. So what is the nullity?
3.
3.
Okay.
So it's maximally not 1-to-1, right? and maximally not onto. It's the worst. It's the furthest you can get from being an isomorphism. Because everything goes to one vector, and since the 0 vector goes to the 0 vector, everything goes to the 0 vector. That's the only way to get nullity equal to the domain. Okay, well, we're out of time. Hopefully this is what you should do is treat assignment 5 in 2 halves. The first half is, I mean, there's a few problems. The problems 1 through 5 you can work on. You have one, because they're all this range, space, rank, kernel, nullity. And then 6 goes on and mentions matrices, right? 7 mentions matrices. 8 mentions matrices. 9 mentions matrices. 10 matrices. So the 5 through 10 all have to do with matrices, which represent maps, which we will start next week. This is we've got, even though this is a long chapter and there's like a lot of stuff in it, we've gone over the essential things to enable you to do the homework problems. And I think the regex exercises. Patrick, you have a question?
Yeah, if you don't mind, can we run through example 2 again? I just want to make sure.
Let me